Okay, folks, today we're multi-steppy factoring equations. I've got a few examples, and you have to put together all the methods of factoring that you know. If you watch my previous videos, you can see some of that, but this is just a quickie review of the difference of two squares. You have to recognize what squares are, and again, this is very quick, just a reminder, if we square an integer, we get its perfect square number, 4, 9, 16, 25. Recognizing those up to 144 is good. Go back to my previous videos if you want to see a more comprehensive list and explanation. So, this is a binomial. It's the difference, means subtraction, of two squares. 16 is a perfect square. 4 times 4 makes 16. X to the 8th is also a perfect square because x to the 4th times x to the 4th is x to the 8th. You have to remember your rules for exponents. You add your exponents when you multiply them. Well, so I have even exponents. When I have even exponents, they would be perfect squares. So I have to take the difference, and it's a format. You see the plus and the minus. We take the square root of 16 and write it twice. The square root of x to the 8th, we write it twice. And then we stop, right? No, Miss Malone, it's obvious you don't. No, we don't. But that is what a lot of students want to do. Must remember to factor completely. This is also the difference between two squares again. So we do the same process we did here with this binomial. The square root of the square root of 4 is 2. The square root of x to the 4th is x squared. And we put those in the binomial format with a plus and a minus. And no, it doesn't matter if we have a minus here and a plus here. I've had students ask me that. It does not matter at all. All right, so let's do a few examples together. So number 2, 81 x to the 8th minus 1. All right, 81 is a perfect square, 9 times 9. And of course, 1 is perfect everything. Perfect square, perfect cube. All right, so let's do our tricky little format, plus and a minus sign. What's 81, the square root of 81? Well, that would be 9. I write it twice. And the square root of x to the 8th would be x to the 4th power. And there we go. I've done that. Now what's the square root of 1? Well, that would be 1. All right, and just like before, you're not getting tricked now, right? We can see that this is a difference, subtraction of two squares. So we're going to do the same process again. The square root of 9x to the 4th is 3x squared. And the square root of 1 is 1. And of course, just to change it up, I'm going to put a minus and then the plus. Oh my God. All right, but these are perfect squares. Why am I not factoring them? Because this is the sum of perfect squares, and you cannot do that. So don't ever go farther than this. This is your final answer. Don't get tricked by that. I know students who do. 125 x to the 5th minus 180 x. All right, next example. Well, those are not perfect squares, so what's going on here? And I see x's, so the first thing to do here is remember that sometimes the very first thing we should do is pull out the greatest common factor. What is that going to be? Well, we have these two numbers, 5 ending in 5 and 0, so I know 5 goes into both of those. And of course, there's the x to the 5th and the x. And if you need help with your variables, I did a video on just simplifying and factoring out variables. All right, let's do this. 5x is the GCF. 5 times what gives me 125? Think of quarters. How many quarters do we need to make 125, right? And how many x's are left when we pull one out? Only 4. Now how many times is 5 going to 180? That's 36 times. And not surprising, we can go farther. These are perfect squares. So let's continue. Now the 5x keeps coming on down. Don't lose them. It's got to stay with the pack. All right, 25x to the 4th. The square root would be 5x squared. 36, the square root of 36 is 6. And putting a minus and a 5x squared plus 6. Are we done? No, we're not. Because here we go. The difference here between two, oh, look, they're not squares. So are we done? Yes, we are. Not perfect squares at all. All right, next one. And let's continue. X to the 4th minus 16. I have even exponent. I have a perfect square. I can do my template here. Square root of x to the 4th, x squared. The square root of 16 is 4, and I write those twice. One with a plus, one with a minus. Can I continue? Well, in this case, yes, we can. That is perfect squares. So again, carry this down. Can't leave. And the square root of both of those, the square root of x squared is x. Put a plus, put a minus, and the square root of 4 is 2. That, folks, is the final answer there. Let's do another one with a GCF, but this one is actually a trinomial. Wow. Okay, let's find the greatest common factor. Give me a second. What do you think it is? Hopefully, you're saying it's x squared. Only pull out the smallest number of in the exponents because that's what they have in common. Again, you could look at a previous video for kind of like a picture of what that looks like. But there's the GCF. X to the 4th, if I pull out x squared, I get x squared plus 13x. Took 2 away. 2 plus 1 is 3. Minus 30. Pulled out the x squared. So now you have to know how to factor trinomials. And so my question is, what can I multiply to get negative 30, but add to get positive 13? And there's lots of choices, but the pair that works is negative 15 times 2. Not negative 15 times 2. It would be 15 times negative 2. There we go. Gotta make sure those work out. 15 plus negative 2 is 13, and that is positive. Okay, so x squared still trucking along, coming down. And I'm going to make my template again. Take the x squared, and I kind of divvy it up. And take these two numbers right here, plus 15 and minus 2. And we can check that here to make sure. If we multiply 15 times negative 2, we get 30. But if we add these two numbers, 15 minus 2, we get positive 13. So we're good. And we can check it off. We're so good. All right. I put a few down at the bottom for you to try. You can pause your video now. Well, copy them down. Pause the video. Then I'm going to put up my answer. And you can compare your work with mine and see how you did. Hope you paused it. All right, here's our final answer. And there's all the work showing how this needed to be factored again. And the final answer here was this. Again, factoring a trinomial, that's the question you need to ask yourself. And there's your final answer. Okay, folks, I hope you did well. And it's been a lot of fun, multi-step factoring. See you again next time. Bye.